let's go ahead and set up our equations for these two masses. Now, I defined in the last video that the forwards direction meant that big M moves to the right and little m slides or falls downwards. And so I want to make sure that I build that into my free body diagrams here. So I'm just going to be clear that the downward direction for little m is positive. And for big M, moving to the right is considered positive motion. And on that basis, I'm going to set up my equations for big M and for little m using Newton's second law. So what Newton's second law actually says is when you combine all the forces acting in a given direction, the effect is that they make the mass accelerate. If they're balanced, that acceleration is exactly zero, and the thing either coasts at a steady speed in a straight line or it remains not moving. Of course, I got my equations for little m too. So in the horizontal direction, I have the tension makes the big mass accelerate. And in the vertical, so this is in the x direction. In the y direction, in the vertical direction, I have the normal force acting up, and it's in a tug of war with the weight. Now, we don't see the block fly up into the air, nor do we see it crash through the table. So that means these two forces have a tug of war, and they cancel each other out. And then for the mass that's hanging off the edge of the table, well, we would define downwards as the positive direction. That means this weight force is the positive force, and the tension force is the negative. So we have the weight of little m dragging the block down competes with the tension. And since this block falls down and actually speeds up as it's falling, the effect is that this little mass accelerates. Now let's see what we can do to throw in some numbers. We know it's a 5 kilogram block hanging off the edge, a 10 kilogram block on the table, and maybe this can kind of help us solve some things. So here, I know the tension is going to be 10 times A. And for little m, I know that its weight is going to be 5 kilograms times 10. Again, that's little m times g minus the tension equals little m, 5 times A. And what I can do now is substitute this dude into here. So when I go ahead and do that, I'm going to end up getting that, combining these equations, 50 minus 10a equals 5a, and that's going to give me a is 3.33 meters per second squared. And when I go ahead and plug this back into, here, I'm going to end up getting a tension of 33.3 newtons. So that's how to do this basic problem. And in the next video, we're actually going to do this with variables only, because in the AP exam, we only want to do things with letters because that's how they're actually going to give it to us.